three classes: those who truly see, those who see when shown, those who do not see. Although the popular quote shown on screen may not necessarily be Da Vinci's, it captures the essence of teaching. The first and the third classes do not need any instruction. Those who belong to the first class are blessed with profound insight and recognize the truth immediately. Those who belong to the third class remain unenlightened despite all efforts. But then there is the second class, the largest and most important one. Those people who grasp concepts and see the truth when they are taught. This video is for all of you belonging to the second class. I hope that you see after having watched it. These days, students do not buy physical textbooks. They always present an excuse why they do it. The high price of textbooks is the top excuse. But this is a problem students created on their own. Good publishers invest considerable amounts of money in the production of high-quality books. When they sell them, they want to recover their investment and make a profit. It does not matter if they sell 1 copy or 1 million copies of a book. They just divide the total amount by the number of copies. The more the students who buy physical textbooks, the more the textbook prices drop. There is evidence that students who use physical books for studying perform better. Students who learn scattered content for their discipline from scattered providers of knowledge. Effectively, they learn nothing. Neither they can be confident that what they learn from them is correct. And students who accumulate ebooks, they create great electronic collections of books which are rarely read. Reading technical material on a screen is tiresome and eye-straining. The habit of not buying physical textbooks is the greatest mistake a student can commit. In this video, I will elaborate on this mistake, and I explain how students should study to build strong knowledge. The discussion spans 2/3 of the video, and the information should be of interest to all students. In the last 1/3 of the video, I provide suggestions of introductory physics and calculus books to beginning physics and engineering students who wish to combine quality study with quality texts. Before Gutenberg's printing press in mid-1450s, the total number of manuscript books in all of Europe was very small, likely in the tens of thousands, with estimates around 30,000 total books. The books were held primarily in monasteries, universities, and private collections, making them incredibly rare, expensive, and accessible only to the elite. Printing revolutionized who had access to knowledge. It allowed every person to learn science. That is, every person willing to study books. This accelerated the progress of the human civilization. Ironically, this progress was to create the social media and kill humanity's desire to read quality books by distinguished and knowledgeable writers. The books were replaced by questionable quality, entertaining videos produced by scientifically unqualified and ignorant media celebrities. As the dramatic abandoning of book reading was taking hold, the quality of the content in textbooks was dropping, but the aesthetic quality was increasing. This trend had started earlier, but the era of social media accelerated it. The publishers thought that diluting the content of a book would keep them relevant. It didn't. Publishers also introduced ebooks, e-homework, and e-tutors. Unfortunately, every new tool contributed more to the deterioration of the quality of students. And as a result, today's students expect that any course is delivered digitally. They cannot put on paper anything anymore. They struggle to write a few meaningful sentences. And when they manage to write any sentences, their handwriting is that of an alien alphabet. The Latin alphabet is unrecognizable and the Greek alphabet undistinguishable from the Chinese. They cannot solve any problem unless they activate the hints of the e-homework. They cannot even identify the topic of the homework if the e-tutor does not specify and summarize it. But let's leave anecdotal statements aside and look at published data in education journals. Every study that I know supports that students who read printed books perform better than students who read ebooks. I will present only 4 of these studies. In a research paper published by Cixin Liao et al. In the education journal Trends in Cognitive Sciences, the authors document that reading on screens is an inferior way to absorb and retain information. The reason lies in the evolution of our brains. Compared to speaking and listening, which come naturally to humans, we have not evolved to read. Reading is an activity that emerged about 5,500 years ago, and humans can master it only with 10 to 15 years of training. Reading on screens is an activity that has appeared recently. It creates a new challenge for the human brain, which did not have any time to adjust. When reading, the time you have available is also a factor. For readers with limited time, the comprehension drops on screen compared to paper. The effect is more pronounced for less skilled readers, and it increases the reader's susceptibility to misinformation. In fact, another research paper by Lydia Altamula et al. Claims comprehension is 6 to 8 times better when using physical books. Reading on screens can also impact the students' attention spans. A study of preschoolers showed that after 6 weeks, the children who watched the story on screen performed significantly worse on attention tests and exhibited brain wave patterns similar to children with ADHD. And finally, a study for older students by Nicholas Wade used eye-tracking technology and revealed that those reading physical books approach the material more carefully, frequently rereading important details. In contrast, students reading on screens tended to skim, leading to lower reading comprehension scores. From the previous discussion, it becomes evident that students must read physical textbooks. Electronic readers should not replace bookcases, and e-books should not replace physical books. Even worse than e-books is the habit to watch YouTube videos, which present scattered material from random YouTubers with no proved educational qualifications. Hence, my recommendations are as follows. 1. Having physical books is important. Always buy at least the required textbooks for your classes. If you can afford, buy the recommended books too. 2. Unfortunately, in our days, screens are unavoidable. However, you can balance screen time with paper reading. I own a huge number of physical books, the same books I own in electronic format. I use the latter when I am away from home traveling, but my first choice is always to open the printed version when I am at home. 3. Always use printed materials for studying. If you only have e-books and electronic study guides, use a printer to create physical copies. 4. YouTube videos should never replace a textbook. Use them only as a supplement, assuming that the videos have been produced by a person knowledgeable on the topic. Another point which needs discussion is that of the meaning of the words study and understanding. The two are very tightly related, since understudying is the result of studying. When I refer to any of the two words, I imply both, since if I have understood a topic, I had to study it first, and if I have truly studied a topic, then I have understood it. The most common behavior of students is to say, I understand the theory. I just cannot solve the problems. To this, my response has always been, you do not understand the theory. If you did, then you would be able to solve the problems, or at least to know what the approach should be. Then I prove my point by asking them to state precisely something from the topic they claim they have studied. They always fail miserably. I have yet to discover a student for whom the statement, I understand the theory, I just cannot solve the problems, is valid. But why do the students feel that they have studied when the instructors claim the opposite? The root of the discrepancy is found in the meaning of the word study assigned by each party. Usually when students say, I have studied the book, they mean they have looked at it. As a result, they remember only what the topic was, but they cannot reproduce anything else. I have looked at a lot of newspapers and media outlets too. I remember what the stories were about, but I cannot reproduce them. More importantly, I cannot answer questions that refer to specific details of the stories. Reading an article in the news is not studying. Studying implies considerable mental effort to make ours everything what we read. At the end of the studying, we should be able to reproduce what we read without any help from the book or any person. A student who has studied the textbook should be able to recite axioms and theorems with precision, not in vague ways. And he should be able to reproduce the proofs at any time effortlessly. This is a good point to mention an incident between Euclid and King Ptolemy I, the savior. The incident is reported by Proclus, the successor. After King Alexander's death, his general Ptolemy went on to found the Ptolemaic kingdom centered on Egypt. With him and his descendants, Egypt became a thriving bastion of Hellenistic culture. Ptolemy was interested in arts and sciences. He personally sponsored the great mathematician Euclid. However, he found Euclid's work, The Elements, too long to study, so he asked if there were a faster way to master it instead of reading the 13 volumes. So, Euclid famously responded, "Sire, there is no royal road to geometry." Students should always remember this story and recognize that if there is no pain, there is no gain. True knowledge is the product of time-consuming, meticulous, and laborious work. And not even a king can bypass the requirements. To check if you know something, you can use Feynman's technique. Richard Feynman was an American physicist who received the Nobel Prize for his work on quantum electrodynamics. His technique to test if you know something and learn it better is to teach the topic to someone who knows nothing about it. In fact, you do not even need another person present. You can make the presentation in front of a blackboard alone or write on a piece of paper. If the presentation is not optimal, then you try again and again and again until you can explain the topic in a simple and concise way. When you reach this point, you have achieved knowledge. Now, you know what true studying and true knowledge are. Apply it correctly, and you can reach the top. However, this cannot be done overnight. You need to do one step at a time and start at the very beginning. The starting point is the introductory books of your major. Buy them, study them, know all content in them. Introductory books are thick and heavy. There's a reason for this. Publishers would prefer to print thin books to reduce the cost of production. Therefore, if they print thick books, it automatically implies that there are important reasons. Introductory books teach all topics in a unified bird's-eye view to help students develop intuition and promote their understanding how everything connects in the big picture. Each topic contained within becomes an advanced course later. The advanced course cannot be understood unless one has mastered the knowledge of the intro course. Physics and engineering majors should study a calculus text and an introductory physics text. Publishers offer them in a single volume or as a 2- and 3-volume sets. I do like the 3-volume sets since they provide a way to organize the topics within specific boundaries. The calculus text teaches all necessary tools to be successful in physics, engineering, and all quantitative science disciplines. It leads the way to the specialized courses of ordinary differential equations, partial differential equations, vector analysis, and differential geometry, and these to more specialized courses. You have heard that mathematics is the language of the universe. Without mastering calculus, you will struggle in sciences. The introductory physics text offers a survey of all areas of physics. It leads the way to classical mechanics, statistical mechanics, electromagnetism, optics, special relativity, and quantum mechanics, and these to more exciting courses, such as condensed matter physics, nuclear physics, and particle physics. Here is a selection of my preferred intro physics and calculus books. In the decade of 60s, a revision of the physics and math curriculum in the USA led to the writing of many great introductory physics texts and calculus books. None of them survive in the original form, and the majority of them are out of print. The exception is the 3-volume text by Feynman. Feynman's eccentric style has produced a quite unique text which presents the material in a non-traditional way. Although I like unique books, I'm not a big fan of the 1st and 3rd volume. Perhaps in a future video, I will explain the reasons. However, I think that the 2nd volume is excellent. I really love the text by Marcelo Alonso and Edward Finn. It has always been the text that I use as the benchmark to judge other texts. Unfortunately, and inexplicably, it was abandoned by instructors. With today's standards, the original edition would be considered a hard book for an introductory course. There's a 1992 edition by Addison Wesley as a revised, single paperback volume, but it does no justice to the original text. Even this edition is out of print today. The lack of full-color photos and its denser content led to its demise. A popular text from the 60s which still survives today in a modified form is that of Robert Resnick and David Halliday. The modified version has been produced by Kenneth Crane, and it's published as a 2-volume, 2-color work. A full-color version has been produced by Joel Walker, and it's marketed for all science majors under the title Fundamentals of Physics. Among all books that have been written more recently for introductory physics, I really like David Morin's book, Introduction to Classical Mechanics with Problems and Solutions, aimed for physics majors. Although it contains standard topics, the collection of problems has a very distinct flavor. Switching to calculus, I have always liked Tom Apostle's two-volume text. Similarly to the case of the Alonso and Finn physics text, these days Apostle's text is considered a hard one. However, is still in print. Among the numerous bulky texts with full color that are in use today for the introductory calculus course, I like Thomas's Calculus with Early Transcendentals, which is based on the original text by George Thomas, and it has been edited by various mathematicians. And with the last comment, I have concluded this video. I hope you liked it. If you did, please subscribe to my channel to help the creation of more videos. Thanks a lot for your support.